What is algorithm? In computer programming terms, an algorithm is a set of well-defined instructions to solve a particular problem. It takes a set of input and produces a desired output. So, an algorithm is the step-by-step, unambiguous instructions to solve a given problem. An example for an algorithm, like adding two numbers. In order to add two numbers, you should take two numbers input, okay? So we have number one, we have a variable called number one, and we have the user entered number 4. So 4 is stored inside num1 variable. And the other variable is listening for the user input, and the user input is 70. So 70 is like stored inside num2 variable. Add numbers using the plus operator in the memory and the CPU. Do this in the arithmetic and logical unit. So this will result in giving us a new result, a new variable called sum, which is 74. So we have stored 74 inside the sum variable. Another example of algorithms. To find the largest number among three numbers. The first step in computer engineering or computer science and in programming, you need to start the program, run it, declare variables A, B, and C. So we have three variables, num1, 2, and 3. Read the variables ABC or num1, num2, num3. So A would be a result in 1, 4, 1, which is the user input. B or num2 would be the input of the user, which is 70, and 3. Num3 or C is 12. These are the reading of the variable. So we have created declared variables. We have initiate the data inside them and store the data that entered by the user inside them. Now we need to make the comparison. So if num1 greater than num2, and this is the case here, so num1 is greater than num2, we took num1 as the bigger between the num1 and 2. Okay? Then we are going to compare num1 with num3. Since num1 is greater than num2, so no need to compare num2 with the num3. We take num1 and compare it with num3. And since num1 is greater than num3, so num1 is the greatest among the three given inputs, A, B, C, or num1, num2, and num3. Okay? There is another way and another thing that we should consider. Maybe the first number or num1 is not greater than num2. So there is an else condition. So if A greater than B, and this is our case, so it works fine. And we should consider all the cases. We need to cover all the cases inside a good algorithm in order not to have bugs or errors during running the program. So if B greater than C, if B greater than A, then proceed. B greater than C, then display B is the largest. Otherwise, C is the greatest number. And step number 5, stop the program. Let's take an algorithm 3. Find the root of the quadratic equation ax squared plus bx plus c equal to 0. In order to solve like this example, we should declare three variables, A, B, and C. We store A as 1 because it's multiplied by 1. For example, the user entered 1. B, storing it inside it 2. The user entered 2. And C, the user entered 1 and stored inside C. Now, we need to declare another variable called determinant. This determinant is calculated by b squared minus 4ac. This is the delta, or the determinant. So the determinant of this equation, the user entered a as 1, b as 2, and c as 1. The determinant of this would be equal to 0. This result, or the determinant, will determine the roots of our quadratic equation. Either they are real or they are imaginary. So, if d greater than or equal to 0, there are two real roots. Or if d less than 0, we will see the complex roots. So, if d greater than 0 or equal to 0, then create two other variables, r1 and r2. Okay, we have a, b, and c, d capital, and r1 and r2 till now. r1 and r2 are representing the roots of this equation. So, r1 is calculated by minus b plus radical b squared minus 4ac over 2a. And in this case, it is equal to minus 1. And r2 is calculated by minus b minus radical b squared minus 4ac over 2a. And this example will result in r1 equal r2, which is the double roots when determinant is equal to 0. If d greater than 0, then we have two distinct roots. Now, if d less than 0, there is a real part which is calculated by minus b over 2a, and an imaginary part, radical b squared minus 4ac over 2a. Okay, so we need now to calculate the roots by putting the real part plus j times ip, and r2 is a real part minus j times ip. In this case, we need to create two variables, r1 and r2, and we calculate the real part and the imaginary part and multiply them by j. So, this complexity in a small quadratic equation. So, how to solve this equation, we will learn later on how to write the codes responsible for making this algorithm working on many coding languages. Now, to see the algorithms in our daily lives, consider a teacher. So consider a teacher need to sort the papers for the students in alphabetical order. This type of task is similar to the function of a sorting algorithm, like a bucket sort. And we will learn about these sorting algorithms later on through this course. By looking at only the first letter of the first name, you can remove a lot of unnecessary information, like the student last name, the student name, and the student age, or the student class, or whatever, and the date of the exam. So we need the first letter of the first name in order to sort them alphabetically. Algorithms in our daily life also. So think about arrangement of leaderboard game. And you need an algorithm like helping you to find the smallest or largest number in a list of thousands of numbers. So you need an algorithm to find the correct number and the correct score. Or you need to keep track of the highest score in a video game. Or you need to find out which seats on a train or airplane are occupied, or finding or listing results from search engines like Google, and providing the instructions that tell you how to get from one location to another with the shortest way using Google Maps. These algorithms also, we are going to learn more about them through this course.